Okay, so so this week um, we'll do some method about comparing. How to compare with a string, how to compare with numbers using a method. Okay, so it's very different when you're using the operator, like a relational operator, um, logic operator. So this we're using the method. Okay, so so first we review, something we learned last week. So first, we learned about the if else, right? If else if, and if statements. Okay, so there's something different between if statement and if else, or if else if else. Okay, for the if statement, if single if statement, which means there's only one true block or non-block can be executed. Okay, but for the if else or if else if, okay, you have to execute one statement. Okay, one block. Okay, so in this example, this is an example of if else if. Okay, so you can see this example, we have multiple conditions. Okay, but there is only one block can be executed. Okay, either this one or this one or this one or this one. Okay, but there's no way you can execute both of them or three of them or four of them. Okay, this is what I say. It's only one block can be executed for the if else if or if else. Okay, but what I say is if you have only one if statement, okay, you probably this condition will be true. Okay, that means you have true block can be executed. Okay, but if this condition return false, there's no block can be executed for this if statement. Okay, another thing I want to mention is, you know, if you if you see keyword else, if you say the one else, you need to make sure this another if statement have to be paired with L statement. Okay? Otherwise, there's some problem will come out. So one of problem we call is dangling else. Okay, which means one of else statement, there's no other if statements to be paired. Okay? Let's take an example. So in this example, we're trying to, to help teacher to get students' grade for the letter grade. Okay, so if grade is greater than 90, okay, or equal to 90, we print out A. Okay, if it's larger than 97, we give plus. Otherwise, we give a minus. Okay, we have another condition. If the grade is greater or equal to 80, okay, we print out is B. Based on this, from 80 to 89. So basically, we can apply them with plus and a minus, right? For the rest of the condition, we all, okay, in this case, we all print F. Okay, but there's something you can improve for this code. Can you improve this code, maybe reduce some code? Still can, get the same result? let's say this part. So basically, this part and this part, they are doing the same thing. They're trying to give the plus or minus, right? And first digit is only, increase or decrease by 1. Since I said, when we say this else statement, if else statement, only one block can be executed. If say this one. How about this one? So get rid of it, okay? So first, we're trying to get A or B, right? Or F. So in this paired if-else statement, only one block can be executed, right? So for example, our grade is 98. Okay, for example, 98. Okay, so which block can be executed? This one, right? Correct? Okay. After that, we direct go to the next statement. Right? Because only one block can be executed. So which means this once this block execute, we have to go to the next statement. Okay? So next statement is this if statement. Right? Okay, once we go to this statement, we check 98. Okay, so this is 98. So 98 is greater than 60, right? So which means we need to go to this block. Once we go to this block, so 98 model 10, what's the result? 8. Okay, so 98 divided by 10, what's the remainder? Remainder is 8, right? So this is 8. Once you get 8, you print out plus. Okay, so basically, in this code, we only use this part of code once, right? But if this one, the same example, if here I give more condition, okay, condition 3, else if condition 4, we need to copy paste all those, the same code to the rest of condition, right? So which make your code is hard to read and looks very complex, right? So if we can do in this way, so only thing you need to do, just print B, A, B, C, D based on different condition. That's the last statement using the same code once, right? Does that make sense? Okay, so the same thing. If you AD, okay, print B, right? So we compare this one, it's written true. So 80. So 80 divided by 10, there's no remainder, right? Right? So which is 0. We go here. So you print minus. So we basically combine these two results together. get our final result, B minus. All right? Question? 82? Is still 2? Yep. Yes. Yes. You say 84? So 4. So basically there's no 4, right? So none of the statements will be. Yeah. If you best down over there, you have default one, right? Question? Make sense? Okay. Let's say this part of code. There's many problems and many mistakes, okay, come from your lab assignment. Okay, can you find any of the problems or, mistake? Can you identify them? Okay, right? The condition only can return true or false. So obviously x plus 1, return true or false, right? Anything else? You mean this one? So Z? Yep. Okay. So that's right, okay? So first, because if else statements have to be paired, right? So this one and this one is paired, right? So this actual else statement, okay, is dangling, okay? And another thing is the scope for the Z. We define this Z in this block, okay? Which means you cannot use this Z in the rest of other block. It's only affect in this block. All right? Anything else? Anything else? One more mistake. Right, okay. We can change to the equality operator other than assign, right? So you assign false to the D. Basically, this is a assignment, not Boolean expression to return true or false. Okay. So I just highlight them, each of them out. Okay. Okay. Question? Any question? Okay. Let's do this one. So sometimes we're trying to compare with a floating number, okay? And we try to add a floating number in a Java or other programming language, okay? In this one, so basically we define a value which is double, right? So each value, so value we just keep increasing by 0.1. We add them 11 times. Okay, so what's the result? 1.1. There's any other? Basically, the results will be something like this. Okay, because in a Java or in other programming language, it's easy you can express any number, integer number, using a binary. Okay, but it's very hard to represent floating point using the binary. Okay, in order, when trying to give a number using the binary, they will get some number closest to that floating number. For example, okay, 0.1. In a Java, they probably give a number is 0.0999997. Okay? As a result, if you do something, like this, okay, you add them 11 times or 1,000 times, probably the result is not your expected. Okay? How solve this problem? One of the ways we can use is threshold. Okay, basically we give our expected number and find the difference with the result. Okay, so basically first add them all, and this is our expected number, okay, 1.1. And threshold is 0.00001. What we need to do is we're trying to find the difference, okay, between the result and your expected value. Okay, if this difference is smaller than the threshold you set, we consider this is a number we want. Okay, so we think they are equal. Yes. You can define by yourself. Okay, so this threshold you can define by yourself. Okay, it depends on users' requirement. They probably say, okay, we probably want point more zeros. Okay, so which means you need a very accurate result. Okay, if you reduce to 0, still be a threshold. Okay, all right. So in this example, basically what you need to do is first get your expected one. Second, try to set the threshold. Okay, then you find a difference. Okay. So this method is from the math class. Okay, ABS. It's help you to get absolute number. Okay, so everyone know what is absolute number, right? So if a -1, absolute will be 1. Okay, then you compare with threshold. So basically, what we want to do is plus or minus the threshold, right? You can go up 0.0001 or you can go down 0.0001. Okay, in this range, we think they are equal. Okay, this is the reason we're using the absolute method. Okay, to compare with a threshold. Okay, question? Make sense? Does that make sense? Okay, good. There's another way we can do. We're using a class to help you to improve this procession. Okay, so one of the class we call the big decimal. Okay, in the big decimal, basically you put this one of the floating number into a class. Okay, and this class, we can take them as a string or with a number. Okay, so currently you don't have to know, with anything about this class, big decimal, but you should know is this class help you to do all the calculation. There's no any point losing. Okay, for example, if we define an object, okay, using the big decimal, okay, so we have two big decimal. Big decimal 1, big decimal 2. Okay, we want to compare them. So one of the results we want to do is big decimal A plus big decimal B. So basically these two numbers, we try to add them. Okay, if we back to the example, we try to add them 11 times. So over here, what we can do 0.0. This one 0.1. We add them 11 times. So there's no anything losing. So basically, if this one time 11 times, so the result will be 1.1. Okay, so basically this is using a class to help you to get the result. All right, so right now there are two ways, right? One way we use this threshold. Okay, we set threshold, and if the smaller your threshold you set, we think this is equal. Okay, there's nothing you should consider. Another one we're using class, big decimal. Okay, to put a number into there using a method add, subtract, multiply, divide to do the calculation. So basically we didn't use plus, divide, minus, time, the operator. We're using a method to do this. Okay, so using a method, they help you to improve this precision. Okay, problem, question? Okay, make sure you understand this. Okay, another one is we try to compare with the object. Okay, so some of you, I don't know how many of you still remember what's the difference between object and the class. Yes. Right. Okay. So the object is more precise and unique. Okay. If you compare with a class. So how to unique? Okay. Let's say this example. How is that unique? Okay. So basically, this part of the code, what we will do is we try to create object. Okay. So how many objects we have for this code? one object or two. Two. One. Tell me how many objects is there? One. One. Okay. There's two objects. Okay. Once you see here, one new, two new. Basically, we create two objects. Okay. Yes. Yeah. Did you remember the example I said? For example, in our class we have two Z. Okay. Are they the same? No. Okay, because they are different. How to identify them? Probably using the the student's ID, right? Or the address they are living, or their parent. You know, they have a different parent name. Okay, they live in different address. Okay, so in the Java, okay, we define them. You know, even they have same value, but they probably locate as different memory address. Okay. If we consider this is a memory space in your computer, okay, one ZAC could be here, another ZAC could be here, okay, but they are different, right? Right? So basically, in this one, we have two objects, okay? One object we use in object reference we called S1, okay? Another object we use object reference as S3. Okay, no matter here, you know, they're using the same name or same numbers there, we still consider they are different objects. Okay? After that, in this line, what that mean? The second line. What that mean? Students S2. What? Exchange. Exchange is what? Okay. So what that mean? S2. Is S1 assigned to S2 or S2 assigned to S1? First, tell me. Okay. S1 assigned to S2. Okay, which means S2 point to the object which S1 point. That makes sense? Okay, because we want to S2 share the same object with S1. That makes sense? Okay. If I write like this, S2 equal to, what that mean? We give a number to S2, right? So right now, S2 is 2, right? So right now, S1 is 2. Then I put S1 there. Same thing, okay? They share the same value, okay, with reach S1 point. Right? Make sense? Make sense? Okay. What that mean for the S1, S4 equal to none? It means S4 point to nothing. Okay, there's nothing you can point for S4 right now. Okay, then tell me what's the return for B1, B2, B3? What's the value? What's the value for B1? David? False. B2. What's the value for B2? True. How about B3? True, right? Okay. So everyone agree with that? The result? False, true, true. Or if you have any different, yeah. Okay. Um, the next slide will give a definition. Okay. So, so we can use another method. Okay. Since this one, many people, I don't understand why S1 is not equal to S3. Okay. So, first of all, we're not comparing with their value. Okay. Those few values, we do not compare with them using this equality sign. Once you trying to compare them using the equality sign operator, we only compare with memory space. Okay, so for in this one, S1 and S3, they locate at different memory edges, right? So we cannot consider they are same. Okay, but we can use the method which we call equals. Equals. Okay, this method they will compare with the value of the object. Okay, so this one will return true. Okay, because S1 and S3 they have same value for their field, right? So they all have the same name, Jane Smith is number 1. Okay, in this one, this will return true. Okay, let's see an example. The first line we create is S1, right, as object reference. So basically, once you create the object reference, you will reserve space as your memory, okay, as computer memory, right? Then we point S1 to this space, okay? So basically, this is a reference to this space. The next line, we have S2, okay? and this S2 share the same object which S1 point. Okay? So right now S1 and S2, they point to same object. Okay? In the third line, we create another object, right? So will look like this. We create another object, which is located here. Okay, using the object reference S3 to point to this object. All right? Then what we need to do right now, you can see S1 and S2. What's the result? Is that equal? Equal, right? Because S1 and S2 point to the same object. Right? So it's return true. S1 to S3, true or false? False, right? S1 is this one, right? S3, this one. How about this? S1 dot equals S3. So return true because we only compare with value. Okay? So value is the same, right? Okay? So how about S2? Equal to null? False, right? Because S2 still point to the object. Okay? How about S4? True. Okay? Question? Answer your question? Good. Any question? Good. Okay. Let's do another very important part. Okay, how to compare with a string. As I said, a string is a class. Once we use a class, we have different method of the class, right? So in this one, we have two ways to initialize the string object, okay? One of the ways, just a normal way, we're using the new, okay? And put the string value in the constructor, okay? Also, for the string, they have shortcut to assign to initialize, okay? We can directly give string B with the value, okay? So there's two ways we can do, okay? So based on this, first tell me what will be returned for these three statements. So first tell me, are they same? How many objects here? 3. Okay, so basically you have 3 objects. So if you compare with these 3 objects, what will be returned? They are not same, right? A is not same to C, A is not same to B, B is not same to C as well. So all return false. Okay, but how can we compare them? there's a method we call compare to. Okay? So in a compare to, we're using one string dot a method is called compare to with another string. Then compare them. Okay? If this A, the character, the Unicode is large than the B, okay, it will return positive. Okay? If A is smaller than B, it's return negative. Okay, otherwise will return 0, which means A is equal to B. Okay, let's take an example. So first of all, as I said, we compare with Unicode. Okay, so we assign the value Amy to S1, Barry to the name 2. Okay, then we compare them. So first of all, name 1 compare with name 2. How to compare? How to compare? Amy, Barry, okay? If we need to compare, first you compare the first index, okay? A and B, okay? If first character, okay, they are not equal, we can get the result. Obviously, A and B, they are not equal, right? And who is larger and who is less, smaller. So in a Unicode, A to B, okay, we will increase it. Okay, so once we have A is 65, so B will be 66. Okay, so this one, basically we compare with 65 with 66. Okay, so we'll get -1. Okay, all right, how about this one? Amy, Aiden. We will compare first. Are they equal? Yes. So we'll go to the next character. Are they equal? No. Okay, so who will be great? Who will be larger? M and D. Which one will be larger? M. Okay, so if you go to this, you can find M is greater than D. Okay, so it's positive first, right? Because Adam, oh, because A means M is greater than address D. Okay, we subtract that, get the value 9. Okay, how about this one? C3. Okay, so it's the same. You compare each index, okay? B is equal to B, A is equal to A, R is equal to R, R is equal to R, Y is equal to Y. So once we compare each of our index, we find out it's equal, we return 0. Okay, make sense? Make sense? How about this? Tell me what's the result? C1, C2, C3. First tell me, okay, the C1 is positive or negative? Negative. Why is negative? Mhm. Okay. Okay. So basically in this case, so each of them will compare. Okay. For the last ladder, for the name 2, there's no anything to compare. Right? At this time, they will compare the length. Okay, how many characters they have. All right. So first one has 3. This one have 4. Okay. So will be positive. Okay. How about C2? It's negative. Why is negative? Okay. Because B is greater than A. Right? So this will be positive. Let's guess what's the value. What's the value for the C2? Will be 1. Right? Because B is only greater than A for 1, right? How about C3? What's the value for C3? Positive. Okay. Can you guess what the value will be? 9? Okay. Will be 4. Okay. Because once we cannot compare, we only compare with the length. Basically, number of the characters. Okay. For the numbers, name 3 has 4 characters. Okay. For the name 4, this is 0. Okay. So 4 compares 0. We get 4. Okay. So when we're using the compare to method, There's many way, sometimes you can help you to get what's the, the length of the uh, character you want to compare, or can help you to sorting with a different character. Okay, that means, okay, you have Amy, Amy B, Amy A, Amy C. Okay, so different them, you can, to get compare with them, you get the different. Then you can sort with them, you know, you can do some sorting. Okay, to this time as maybe alphabetic, right? Using a alphabetical order. Question, question. Okay, let's do this one. Tell me the positive or negative. Say one. Positive, negative. So we compare basically this one with this one, right? So A and capital A, which one is larger? Okay, the lowercase one, right? So this is positive. Okay, how about this one? So this is Amy, right? With Rob. It's negative. Okay, so R is larger than A. Okay, negative, positive. All right. Okay, how about this? B1, B2, B3. True, false. Okay, first is a false, right? Because they compare with the list two. Okay, basically they are not same, especially same the first letter. Okay, let's guess what's this method used to. True. Okay, so equals ignore case. This method just to tell you we can ignore the case. Okay, all right, so that means everything in here is a lowercase. Okay, so we just compare Amy, lowercase Amy with lowercase Amy. Okay, the value is a return true. Okay, how about this? These three. True. Right? Right? Question? Okay. Last question. Just to tell me, okay, the variable, there's only one from B1 to B4, B8. Only one of the variable will return false. Which one? P3. So you think this is false? B6. Okay. Any other answers? No? Everyone agree with F? B6? Written false? Yes? Okay. So the answer will be B6. Okay, let's do this one together. Okay. So right now, how many objects we have? How many? 3, right? Then we're using different objects reference to point. So P1, P2, P3. Okay. Next line, we try to assign this P2 to P4. So basically right now, P4 share the same objects, okay, as P2, right? How about this one? What that mean? So P4 assigned to the P5. What's the P4 right now? What's the object's P4 point? P2, right? Because we share the P2 objects with P4. Then with P4 to assign P5, which means P5, P4, P2, they point to the same object. Okay, once you get that, it will be very easy to do. Okay, first P1, P2. Okay, this we're trying to compare with value or with the object. Value. Okay, so P1 and P2, the value, they are the same. Okay, this is return true. Okay, second one, P1 dot get name. So name is Jon Snow. Okay, we ignore the case with Jon Snow, which will return true. Okay, and the B3, P5. Okay, so none is not equal to P5. So right now, the P5 point to any object? Yes or no? P5. Yes, right? So this is true, right? So B4. So we get a name for the P2. P2 will be Jon Snow compared with Bob. Okay, so basically it's John with Bob. We compare these two. What's that? J greater than B, right? J is greater than B, which will be positive, right? B5. So who will be equal right now? P5, P4, P2. They all point to same object, right? So this will be true, right? Then B6. So P3 still has object point, right? So this is false. Okay, so P1 is not equal to P4. That's right, right? So P1 is this one. P4 is this one, basically, right? How about this one? P3, name is Jane Snow, is equal to Jane Snow. Okay, the value. Okay, make sense? Okay, so those questions will be in the next exam. Okay, so after next week we have another exam. Okay, later on after fall break, is it fall break or spring break? Oh, fall break. Yeah, yeah. After that time, November 24th or 21st, 21st, 20. Okay. After that, we have final exam. Okay. So after that, we will go completely remote, but I will try to teach everything before the remote start. So you have a remote time, you can prepare for the exam, final exam. Okay. All right, so right now we'll go a little bit faster, but just to make sure, if you have any question, problem, just let me know, okay? No matter in the class or Piazza or send me email, okay? All right, then for today's class, thank you.